Okay, for number 15, we've got, it says if ABCD is a parallelogram with angle D equal to X and angle A equal to 6X plus 5, find the value of X. So see the figure below. If we're looking down here at this figure, we got ABCD right down here. Angle D is equal to X. Angle A is equal to 6X plus 5. And we want to find the value of X. Well, these two angles here are going to be supplementary. So add those together, we get 7X plus 5 equals 180. So I subtract 5 from each side, and that is 7X is equal to 175. I take 175 and divide by 7. In this case, X is going to be equal to 25. Okay, let's go ahead and again, that was number 15. 16 says we've got XYZW is a parallelogram, diagonals XZ and YW that intersect at the point A. If YA is 3G and WA is 2G plus 3, XZ is 6G, find XA. Again, XA is going to be half of that. What I'm going to start with, these are diagonals bisect each other. So I'm going to say 2G plus 3 is equal to 3G. And if I subtract 2G from each side, 3 is equal to G. Now, if I plug 3 in for G, what that tells me is that XZ is 6 times 3, or 18. And if they want to know XA, that's going to be half of 18. So 18 divided by 2. So XA is going to be equal to 9. Okay, we're moving on to number 17. 17 says the measure of the bases of a trapezoid are 12 and 18. What's the measure of the median or the mid-segment? So remember, we take the two bases and add them together, 12 plus 18. We're going to divide that by 2. Well, 12 plus 18 is 30. 30 divided by 2 is 15. Okay, number 18, it says if DEFG is a square, find the measure of angle DEG, which DEG is this measure here. Well, we know that the diagonals in a square bisect the corner angle. So if this is 90, we bisect it. Angle DEG has to be 45 degrees. 19 says in a rhombus, what kind of triangles are formed by the diagonals? So if you think about drawing a rhombus, here's my rhombus, and we know that we draw in our diagonals. We know that all of these sides are going to be the same. These are going to be right angles. So the type of triangles formed there would be right triangles. Okay, 20, last one on this page. If RSTU is a rectangle with angle R is going to be 3x plus 9. And we want to find the value of x. Well, we know in a rectangle, all the angles are 90. So I'm going to say 3x plus 9 equals 90. If I subtract 9, I get 3x equals 81. And if I divide 81 by 3, 81 divided by 3 is 27. So x in this case is going to be 27. So just setting the angle equal to 90. Okay, we're moving on to number 21. 21 says, what value must x and y have in order to be a rectangle? So we've got TLZ. TLZ is going to be x plus 10. ZLP is going to be 3x. We've got TZ is going to be 4y minus 2. And LF, the whole length of this diagonal, is going to be 6y plus 4. we want to find x and y. So first of all, to find x, we know these two angles here add up to 90. So we've got x plus 10 plus 3x equals 90. So we get 4x plus 10 equals 90. We subtract 10, 4x equals 80. We divide by 4, so x is going to be 20. All right. Now for the y values, we've got in a rectangle, they bisect each other and they're the same length. So this 4y minus 2, if I multiply it by 2, that's going to be the length of this other diagonal, which is 6y plus 4. So as I solve that, 8y minus 4 is equal to 6y plus 4. I subtract 6y, so I get 2y equals 8 when I add 4. So y in this case is going to be 4. 22 says find x in the measure of KE. If quadrilateral KITE is a kite, find x and y. Okay, so x is probably the easiest to find because we know that these two sides, smaller sides, have to be equal. So x plus 2 has to equal 13. So if I subtract 2, x is going to be equal to 11. To find my y value, we know that these two angles here have to be the same. So I'm going to just call this y. So if I say 2y plus 132 plus 60, that has to equal 360 because I do have a four-sided figure here. If I add those together, 132 plus 60, I get 192. So 2y plus 192 equals 360. If I take 360 minus the 192, I get 168. And if I take 168 and divide it by 2, I get 84. So y is going to be 84 here. All right, so 23, the next one, says find the following values given that we have a rhombus. They tell us the measure of angle AEB is 3x. So AEB is 3x. And we want to find x. So in a rhombus, we know that the diagonals form right angles. So all we're going to do is we're going to say 3x equals 90. Divided by 3, x is going to be 30 for number 23. Okay, 24 says we have AB is 3x plus 5. And we have BC, which is 5x minus 9. Again, this is a rhombus, so we know that all four sides have to be the same. So I'm going to find x first. 3x plus 5 has to be equal to the 5x minus 9. If I subtract 3x, I get 2x, and I add 9, I get 14. So x is going to be 7. If I plug 7 back in, 3 times 7 is 21 plus 5, so it's going to be 26. So the length of this side is 26. We have four sides, so 26 times the four sides. So 26 times 4 is going to make your perimeter equal to 104. So 104 is going to go right there for number 24. Okay, we're moving on to 25. 25 says given DAC is 3x, so DAC, that's this angle, is 3x. And DAB is the big angle, is 4x plus 10. Again, in a rhombus, the diagonals bisect the corner angles, so I'm going to take that 3x, I'm going to multiply it by 2 and set it equal to that 4x plus 10. So here's what I end up getting. 6x equals 4x plus 10. If I subtract 4x, I get 2x equals 10. So x is going to be equal to 5 for number 25. We also want to know the measure of angle DAB, which if I plug 5 back in, 4 times 5 is going to be 20, plus 10 is going to make DAB 30. So angle DAB is equal to 30 degrees. Again, all I did was plug 5 back in right here for the 4x plus 10. Okay, we're moving on to 26. If ZO is 15, we're looking now at a trapezoid. ZO is 15 and ID is 27. We're going to find the mid-segment, so we're going to do 15 plus 27. Well, 15 plus 27 is 42, and we're going to divide that by 2. So 21 is going to be the length of the mid-segment there for that one. 27, if ZDI is 35, so ZDI is 35. It's this bottom angle. We want to know the measure of angle ZOI. So here's something to think about here. If this bottom angle is 35, this angle has to be 35. So together, that's 70 degrees. So the bottom two angles is 70. We know that if I just call these X, okay, for the missing angles there, those two are the same angle. So 70 plus 2X has to equal 360. So if I take 360 and I subtract 70, that gives me 290, and then I divide that by 2, 145 would have to be the value. Again, 360 is all four angles. These two have to be the same. That's why I called them both X, or the same. And then once I subtracted 70 and divided by 2, that's how I'm getting 145. The next one, ZI, is 6x minus 4, and OD, those are both diagonals in the isosceles trapezoid, so we know those have to be the same. So 6x minus 4 has to equal 2x plus 12. When I solve that, I subtract 2x, so I get 4x, add 4 equals 16. X in this case has to be 4. Okay, the last problem here, negative, we're going to plot the points. So negative 3, 1. That's going to be F. C is 1, 3. H is 5, 1. And S is 1, negative 1. So if I go ahead and I plot the points and go ahead and connect my dots, I'm going to find my slopes of each of the lines. So FC, I'm going up 1, 2 over 1, 2, 4. So 2 over 4 is 1/2. For SH, I'm going up 1, 2, 1, 2, 3, 4. So also 1/2. For CH, I'm going up 1, 2, and I'm going over 1, 2, 3, 4. So up 2 and left 4 is going to be a negative 1/2. And so up 2 and left 4, again, a negative 1/2. Okay, so this would definitely be a parallelogram. Because both pairs of opposite sides have the same slope. It would not be a rectangle because these are not opposite reciprocal slopes. To check to see if it's a rhombus, if I draw in my diagonals here, we notice that CS has a slope of, it's a vertical line, so it's undefined, and FH has a slope of 0. So those are opposite reciprocal. So it is a rhombus. But because it's not a rectangle, but it is a rhombus, this one is not a square. So it's just a parallelogram and a rhombus.